Hello everyone, I hope you all are doing good. So in today's data structure tutorial, we are going to discuss on the concept of graphs, which are non-linear data structures, where it consists of nodes and edges. Okay, uh, nodes are we also call nodes as vertices. So if I have to formally define what do I mean by graph, it is consists of finite set of vertices or nodes and set of edges which connect a pair of nodes. All right. Now, before moving on its implementation, it's better to understand where are we using graph in real-time application. Okay. So if I have to say where are we using it, we use graphs for network implementation, or whenever I have to represent a network, I do use graphs. So it can be your router connection, or it's your telephone network. So telephone network, and even the city, how they are connected, and social media. So social media, it can be LinkedIn, Facebook. Okay, so here like a node is a structure um, that holds the information such as person ID. If I am a person who is using a social media account, then a particular node would be storing the information. It can be my ID, my name, location, and other details. Okay, so similarly, if we are using any application such as Uber to book a cab, so there also we are making use of graph implementation to determine the nearest cab that we can book and to locate the driver's position. Okay, um, moving on to the representation of graph. Here I have a graph of 4 vertices, right? And then I have an edge from vertex 0 to vertex 1. So this is unidirectional, and I can clearly see one bidirectional as well, where I have a link from 0 to 2 and 2 to 0, right? I have a loop to the node itself also, that is my vertex 3. Okay, uh, let's move on to implementation of graph, how we can represent a graph. So here I am going to define a class, and to hold the, for 0, my adjacent vertices are 1 and 2. So to hold this information, I'm going to make use of list. So let's see how we are going to represent our graph. Okay, so class, I'm naming it as my graph, and here for the vertices I'm declaring a variable b, and as I said, I will be using the list as my vertices are int type, so I'm going to put int and my pointer. and I'll name it as adjacent to represent the adjacent vertices. Okay, moving on to the public. Here I am going to make a constructor where I would be passing the vertex, and what I'm going to do, I'm going to assign x to v, and one more step, that is to declare the to create the adjacent list for that particular vertex. So adj equal to new list int for of size x. Okay, semicolon. So we are good with the constructor. Okay, one point. This is parameterized constructor. Okay, and I'm going to define a function by where I would be adding the edges. So for an edge, we have pair of nodes, right? So I'm going to take two parameters, int a comma int b. Okay, so we have defined a class, and here I'm going to define the function, define the add edge function. So how do we do it? Return type, name of the class, name of the function, then the parameters, int a comma int b. So we are using adjacent list, and if I am adding an edge from A to B, what I have to do, I have to add A to the adjacent list of, sorry, I have to add B to the adjacent list of A. So I'm going to access the adjacent list of A, and push back B. Okay, fine. Now in the main function, let's create the object, my graph G. I'm taking 4 vertices, and then I'm just going to call the function add edge. So here we can see I have an edge from 0 to 1. So I'm going to access the adjacent list of 0, and I'm going to add 1 to it. Okay, so 0 comma 1, right? Same way I can put for rest of the edges, g dot add edge 0 comma 2. Then I'll just, okay. Then we have from 1 to 2, 1 comma 2. Then from 2 to 0, 2 comma 0. Then I have from 2 to 3, 2 comma 3. Then I have a loop itself, right? 3 comma 3. Fine. Okay. Okay. We are good till here. Um, So what I'm using parameterized constructor, when I'm making this object, I'm passing 4, which is I'm going to create 4 adjacent lists. The number of vertices 4. I have 4 adjacent lists. In add edge, I'm going to access the list for every vertex. Here I am accessing for the 0th vertex and I'm going to add 1 to it. Accessing the 4th vertex, adding 2 to it. Okay, I'll just explain here. So for the vertex 0, the adjacent list is 1, comma 2. For vertex 1, it is only 2. For vertex 2, it is 0, comma 3. For vertex 3, there is loop itself to 3, so it will be 3. So that is how we are representing our graph, the number of vertices and the adjacent list for every vertex. In the next videos, I'm going to discuss on the breadth first search and depth first search traversal. So we are good in setting our graph. Now let's see how we do the traversal in the next video. I hope you like this video. I'm going to provide the GitHub link in the description section for sure. You can access the link and can play around by adding more edges and performing the other operations. Thank you. Have a good day.